So now what I want to do is I want to move on to one more question, and we're going to do this one together again, and you guys are going to try to help me out a little bit, okay? So some of you guys have already learned, most of you have already learned how to make triple bonds, okay? And if you recall, the way that we make triple bonds is by doing a double elimination of dihalides, okay? Now for some of you, this is going to be new information, meaning you haven't learned this yet, and that's okay. You're going to get to it. I'm just going to show you how to do this here, because this happens to be one of the crucial steps of making an alkynide. In fact, usually what we do is we go from a single bond, then we make a triple bond, and then once we have the triple bond, we can make the alkynide with deprotonation. I'm going to show you how to do all that right here, okay? So here, notice that we have a dihalide, right? Okay, so we have our dihalide, and I'm reacting it with actually 3 equivalents of a strong base. Why would I use 3? That's a very strange number. And it turns out that 2 of those equivalents are going to be used to make the triple bond through double elimination, and then 1 of those equivalents is going to be used to actually make the alkynide. Let me show you how that works. So basically we have hydrogen here, we have a hydrogen here, okay? The red hydrogen can eliminate with the red Br, the blue hydrogen can eliminate with the blue Br, okay? So what that means is that my first equivalent of NH2 negative is going to pull off 1 of the hydrogens and make a double bond that looks like this. Is that cool so far? Okay, and I still have, well, I should have drawn the H probably going up over here, okay? That's the blue H. I still have the blue H left, okay? And I still have the blue Br left, okay? So that was my first equivalent. So that was times 1, okay? Now what about my second equivalent? Well, my second equivalent, this will be times 2, can pull off the other H. So I'm going to do a double elimination. I'm going to make my triple bond, and what that's going to give me is, look, a triple bond. So 1, okay, so now I have a triple bond from the first 2 equivalents of my base, okay? But now I have this third equivalent. What's the third equivalent going to do? Well, if I add my third equivalent, so this is times 3, what that's going to do is it already has a triple bond. This is the sodium alkynide part, and this is the part that all of you guys should know. Basically, what we're going to do is we're going to take the acidic H and we're going to do an acid-base reaction with it. So we're going to take that off and make a negative charge, and what I'm going to end up with now is a sodium alkynide, okay? This is really the only pathway in Organic 1 to make sodium alkynides. We do a double elimination, and then we deprotonate, and then we make our sodium alkynide. Now I want to just point out that your professor doesn't always have to write times 3, okay? In fact, what they might write instead is they might write excess, okay? If they write one of these strong bases, either NaH or NaNH2, in excess, that's really the same thing as them saying times 3. They're just saying react it as far as it will go. So that just means react it all the way to the sodium alkynide. Alright? So now that we're at the sodium alkynide, I'm reacting that with a molecule called CH3I. What the heck is that? Well, if you think about it, that is an alkyl halide, okay? So I just showed you guys in the previous example how to take a nucleophile, react it with an alkyl halide, and get a substitution reaction. So now I'm actually going to stop the video and let you guys try to figure out what the final product looks like. And then when you get out, when you're done, I'll go ahead and show you what it is. Alright? So get started on that.